Okay, today let's do some simplifying radicals together, and then what's on the A2 to A3 quiz worksheet that I gave you yesterday. The back of the quiz worksheet that I gave you that said review, the back, it says what's on the 8.2, 8.3 quiz. The back puzzle is extra credit if you show work. You can't just have the puzzle answer, okay? Show work, and you can do that for extra credit if you'd like. Otherwise, I'm not collecting this because I'm going over the entire thing with you right now, okay? I have in the past collected them, but I've got enough grades. I don't want to collect that one. All right, so now let's go and look at a few radicals together. If you're looking at your page that I told you, which is the page with the multiplication chart, okay, you're going to be looking at the numbers right here on the diagonal. I'm going to review a few problems here with you. Just look now, and you don't have to write anything. Let's just do a few together, watching, and then we're going to do the ones that are on that quiz thing. All right, now, if you had to do the square root of 63, you would be looking on the diagonal, and you would see these numbers. You go to let's see, there's 64 in there, 81, then there's 100, and 121, and 144, etc. Okay, so then you go and you say, well, 63. I definitely don't have to go this high, all right? And I start going down, and I look at the numbers, and I say, would I bother dividing 63 by 49? No. Would I divide it by 36? No, I don't think so. 25? No, it doesn't end in 0 or 5. How about 16? Maybe you might try. Okay, 63 divided by 16 and just check it out. But it doesn't divide evenly. So then you divide by 9, or if you happen to know your times tables well, then you might have figured that out already. Okay, 63 divided by, so I would be breaking this up into 9 times 7. You guys do not have this in front of you. All right, don't be looking for this. You don't have it. Okay, I'm just doing some examples with you right now, so you just think about it. All right, then you can break this apart. The square root of 9 times the square root of 7. The square root of 9 is 3, so this would be simplified to 3 square roots of 7. I'm just going to do a couple more. What is the square root of 64? I actually have students write 2 root something. Okay, what I'm trying to tell you is look and see if it's on that diagonal, and it is. So the square root of 64 is 8. 8 times 8 is 64. 54 can be broken down into, well, let's look up here. Look where 54 is between here. So I start going back down until I find one that divides evenly into it, and it would be 9. So that's 9 times 6. You break that apart into the square root of 9 times the square root of 6. The square root of 9 is 3 because 3 times 3 is 9. You get to come out of jail, start your new life as the number 3. So this would be 3 square roots of 6. He stays in jail. 20, you can't go very far. The only one that divides in here that's a perfect square would be the 4. So we would break 20 into 4 times 5. The square root of 4 times the square root of 5 would give me, the square root of 4 is 2 because it's a twin number. 2 times 2 is 4. So start over outside of the radical as a 2. This guy can't come out. He's not a twin. 2 root 5. All right, let's go to your worksheet. I don't have any like this on the quiz. Okay, so the first thing up was the first thing we did in the chapter. We did the Pythagorean theorem. So that's leg squared plus leg squared equals hypotenuse squared. So we should be looking at this and saying, I know which one's the hypotenuse. It's the longest. That's the hypotenuse. Okay, so we're going to do x squared plus 8.2 squared equals 12.2 squared. So you start working on that calculator. You get 8.2 and you square it by hitting the squared button, which is over here on the left. 8.2 squared is 67.24. You go in your calculator and type 12.2 squared. That's 148.84. Now what? Got to get x squared alone. Subtract 67.24 from both sides. That will give you x squared is equal to something 0.61, 81.6. 8 minus 7 is 1. No, it's 81.6. Now you're going to take the square root of that. Was it 148.24? 0.84, sorry. Minus 67.24. I'll prove it on the calculator. We got 81.6. Now we take the square root of that. And you can hit second, square root, and you can pop this answer in if you don't want to type it by going second and hit the negative button. Puts in this last answer and hit enter. And that's 9.03. Now it did say to do, how did we do that? We did the square root of 81.6. It did say to go to the nearest tenth, so this would be just 9 then if you went to the nearest tenth. Okay, the next one, we're finding the hypotenuse. So I'm going to need to do h squared, or whatever you want to call it, x squared, since it says x. X squared will equal 11.4 squared plus 10.4 squared. Okay, so I'm just going to type that on my calculator. 11.4 squared plus 10.4 squared. Thanks. Just double checking I remembered right. That's 238.12. You don't want to round. Now take the square root of exactly that. So you hit your second. Sorry, wrong one. Second, let's get out of there. Second button, x squared button, and then put in that, I can hit second, negative sign, and I'll put in the last answer and hit enter. 15.4. Of course, you're welcome to type it in. Square root of 238.12, 15.4. And that would be in meters, both of these. Okay. Next, it says, state if the three sides form an acute, obtuse, or a right triangle. This would be on the first page of your ISN, where the Pythagorean theorem is. It is the converse of the Pythagorean theorem. Okay, which says that if c squared equals a squared plus b squared, then you have a right triangle. If c squared is less than a squared plus b squared, then you have an acute triangle. And if c squared is, greater than a squared plus b squared, then your triangle was obtuse. That is in your ISN. What do you need to start with? You need to start with the biggest side every time. So we go 13 squared and we compare it to 10 squared plus 12 squared. You grab your calculator, you put 13 squared and that's 169. You type in 10 squared plus 12 squared, which is 144 added to 44. You find out that 169, you say to yourself, wait, that's smaller, less than 244. So the triangle is acute. You got an acute triangle. Did you already do this? No. All right. 15 you would start with in this one. 15 squared compared to 6 squared plus 12 squared. 15 squared is 225. 6 squared plus 12 squared on your calc would be 180. 225 is greater than 180, therefore this would be an obtuse triangle. Questions about this? And if you got the largest side squared and it was equal, then it would have been right. Got some questions on this on the quiz. You got to show this, guys, on your quiz. Don't just guess obtuse or acute. Write down something for me. Show me you're doing large side versus sum of the smaller two sides squared and added. Okay, next, special right triangles. This would be on page 3 of your ISN, 3 and 4. Page 3 has the 45, 45, 90s, and page 4 has the 30, 60, 90s. You're going to have to flop between them. So the 30, 60, 90 special right triangle, the pattern says that this angle's 60, this angle's 30. I just drew it this way. Then the short leg would be n, the long leg would be n root 3, and the hypotenuse would be 2 times the short leg, 2n. So in this case, I'm missing 2 problems. You're number 5. You have a 5 there, don't you? I just remembered that I'm missing a problem here. Okay, so I'll go ahead and draw those, and then we'll go ahead and use the patterns. Number 5 actually is a 30, 60, 90. It looks like this. So if you're wondering why I was skipping it, I'm not. It says y here, it says x here, and it has a square root of 3 there and a 30 here. Okay, we know this is 60. We know that we have the side across from the 60, which is the side that's labeled n root 3. So what's n? What's the number in front? If it's just the square root of 3, what's the number in front? 1. Okay, which means n is 1. That would be the y value. Okay, so y equals 1, and x is 2 times it, 2. Okay, your number 6 on your paper is a 30, 60, 90 also. Bless you. You're welcome. All right, so there's a 30 there. It's not really drawn to scale, but anyway, this is 8 and this was 6. They gave you the hypotenuse is 6. If you know the hypotenuse, then what the deal it says in your ISN is, given the hypotenuse, divide by 2, and that gives you the short leg, which would be 3. The long leg then is the short leg times the square root of 3. So A is 3 root 3, B is 3. We're good? Okay, going to have to do this in a minute. Now let's go to number 7. 7 has a side with where the 60, opposite the 60. So this is your long leg, and it has no square root of 3. So you go and look at what it says to do. It tells you specifically if you have the long leg with no square root of 3, then take that number, 6, divide it by 3, and put a square root of 3 on it, and that'll give you the short leg. That's going to be 2 square roots of 3. Do you guys know where I was reading from, where I'm actually memorizing what it says in those boxes? You got to be able to go there and find which one to look at and follow what it says. Now, once you know the short leg is 2 root 3, you multiply it by 2 to get the hypotenuse. 2 times 2, you only can hang out with people outside of jail, so that's going to be 4 root 3. Okay. All right, number 8 is a 45, 45, 90, and on that, the pattern in your ISN says the legs are n and n, and those are the sides that make the right angle. They're the same sides, and the hypotenuse is n times the square root of 2. This one has the hypotenuse with no square root of 2. On your worksheet, on your notes, there's a big box at the bottom of that page. And it tells you what to do if you have the hypotenuse with no square root of 2. Find it. In your ISN. You need to know where that's at. It's at the bottom of the page on the 45, 45, 90 page, isn't it? All right. It says if there's no square root of 2 and you got the hypotenuse, it tells you to divide by 2 and put on a square root of 2. Okay? All right, so we go 2 divided by 2, put a square root of 2 on it. That would be 1 square root of 2. And both of those are the same. So x is the square root of 2 and y is the square root of 2. Got to be able to follow those rules. All right, number 9, you got a 30, 60, 90, and that's the hypotenuse. So the short leg, if you're given the hypotenuse, you divide it by 2. So y is going to be 4, And then the short leg times the square root of 3 would give you the long leg. So x is 4 square roots of 3. This is a 45, 45, 90, and now we've got the hypotenuse, and it has a square root of 2 on it. So it says to take it off, and that means the legs are both 3. $11 is a 45, 45, 90. One of the legs is 6, so the other leg is 6. So y is 6, x is 6 root 2. That should be the easiest one. And this is a 30, 60, 90, and that's the short leg is given. If you're given the short leg, you multiply by 2 for the hypotenuse, which would be 4 for m. And then n is short leg 2 times the square root of 3. Good? Okay, now simplify these radicals. Go to your diagonal. 4, 9, 16, 25, 36, 49, 64, 81, 100. That's as high as I need. Wait, 121, 144. All right, I already know the answer to number 16. It's on the diagonal, 12. Okay, back to here. What is the biggest number that divides into 16? It's not 4, guys. I just said the answer. I have no idea how that just came out of my mouth. Weird. Sorry about that. I'm tired. Yeah, it was 16, not 4. All right, so 16 times 3 is 48. So break it up into a perfect square times a non-perfect square, and then simplify the perfect square. Ease the square root of 16 comes out to start his new life as a 4. 4 root 3. Number 14. What's the biggest one in my list that goes into 700? 100. All right, so you break that into a perfect square times a non-perfect square. The perfect square gets to come out of jail. So that's going to be the square root of 100, which is 10. So you got 10 root 7. And you don't have to write all these steps if you don't need to. I'm just showing why it's what it is. And then this one is 16 times 2, not 8 times 4. So this is going to be 4 root 2. Okay, let's do it. I don't even care if you keep that by you. Done. Oops, I need to stop.